Let us consider a magnetic field, a uniform magnetic field towards right direction. And in this one, there is a magnet here. Let us consider this is a magnet suspended in the uniform magnetic field. So this is north and south pole, and on the north pole, F it is equal to mb, force it is acted in the positive direction, and in the opposite direction, F it is equal to minus mb. Right, both are equal in magnitude but in opposite direction. Now, what is the direction of the magnetic movement? Direction of the magnetic movement, it is from south pole to the north. Now, it makes some angle theta with the magnetic field here. Right. It makes some angle theta with the uniform magnetic field. Okay. Now, what happened? So, due to these two forces coupled, a torque is acted. So that torque is nothing but restoring torque. Already we have discussed that one. So what will be the torque formula? Tau it is equal to mb sin theta. In vector notation means it is equal to m cross b. Here I am taking only the magnitude. Tau it is equal to mb sin theta. Now here for a small angle, to rotate the magnet through a small angle theta, the work done. So the work done it is equal to tau into d theta. Work done is equal to force into displacement. In rotational, work done it is equal to, instead of force, we will take the torque here. Torque into angular displacement. Right? Okay. Now here let us see here. So therefore, it will be mb sin theta into d theta. So what will be the work done? The total work done from 0 to 30 degrees. Initially, let us consider the magnet is in equilibrium position. So therefore, the total work done from 0 to 30 degrees dw. So therefore, it is equal to, from integral 0 to 30 degrees, dw1 is equal to mb sin theta d theta. So therefore, work done it is equal. So work done it is equal. So m and b is constant. M and b is constant. So therefore, integral sin theta is nothing but minus cos theta from 0 to 30 degrees. Now here this can be written as mb of cos theta. We can change the limits here from 30 to 0 degrees, like this, to remove the magnet here. Sorry, to remove the negative side. So therefore, W it is equal to mb cos 0 degrees minus cos 30. Okay, now let us substitute the values of m and b also here. So what is the magnetic moment? Magnetic moment value is equal to 20 into b. External magnetic field is equal to 0.3. So 0.3 into cos 0 means it is 1. Minus cos 30 means root 3 by 2. So it is root 3 by 2 here. Right. So finally here point and 0 get cancelled. It is equal to 3 to the 6 by taking 1 by 2 common here, or else by 2 common here. W is equal to 6 by 2 of 2 minus root 3. So therefore here work done in CGS units. So 3 of 2 minus root 3. This is the work done to rotate the magnet in the uniform magnetic field. So that will be the option C now. At the neutral points. At neutral points, BH it is equal to the B equatorial. Okay. Now what is the BH value here? 3.2 into 10 power minus 5 Tesla. It is equal to B equatorial mu naught by 4 pi equatorial M by, this is a magnetic moment, capital M, magnetic moment by Now, according to the problem here, the bar magnet it is of 8 centimeter itself. 2L value is equal to 8 centimeter. Okay. Now it is not a short bar magnet. So therefore we have to use the formula d square plus L square whole power 3 by 2. Now what is the d value here? The d value. This is the d value. And the d value is equal to 3 centimeter. So here 3.2 into 10 power minus 5 is equal to mu naught value 4 pi into 10 power minus 7 by 4 pi into small m into 2l. So capital M is equal to m into 2l. This is the formula for the magnetic movement, and 2l value is equal to 8 centimeter, 8 into 10 power minus 2 meter by d value is equal to 3 centimeter. 3 centimeter square means it is nothing but 9 into 10 power minus 4 plus L value is equal to 2L value is equal to 8 means L value is equal to 4. So therefore 4 centimeter square means 16 into 10 power minus 4 whole power 3 by 2. Okay. So now 4 pi get cancelled. So therefore rewriting this one 3.2 into 10 power minus 5 by cross multiplication we will get here 10 power minus 7 into 10 power minus 2 means 10 power minus 9 into 8 into what about this one? Now 16 plus 9 means it is equal to 25. So 25 into 10 power minus 4 is 12. 5 into 10 power 5 into 10 power minus 2 whole cube. This is the M value, which you will get in SI units. So finally here on calculating this one, the M value it is equal to 0.5 ampere meter. By calculating this one approximately we will get 0.5 ampere meter. But the options are given in CGS units. Okay. Now here 1 ampere is equal to 1 by 10 ab ampere. 1 ampere is equal to 1 by 10 ab ampere. So therefore it is equal to 0.5 into 1 by 10 ab ampere. This is a CGS unit of for the ampere now. Ab ampere. Is meter ni kuda centimeter lo convert cheyali into 100 centimeter. Now calculating this one here 0 and 0 will get cancelled, so therefore 0.5 and 10 and 10 point and 10 kuda cancel ayipothundi. Finally ga will get approximately it is equal to 5 ampere meter, sorry, centimeter. So that will be the option A. Right. Now what is the direction of the magnetic movement? Right. Remember the magnetic movement direction. Magnetic movement which is denoted by M bar. All the magnets are having the same magnetic moments. Magnetic movement M bar is from, means the direction of the magnetic movement it is from south pole to north pole. Okay, now let us see what is the magnetic movement for the first diagram. Magnetic movement, this is the magnetic movement of the first magnet and this is the magnetic movement of the second magnet. Both are at 90 degrees, so therefore net magnetic movement it is equal to root of m square plus m square plus 2m square into cos 90. Cos 90 will be 0, so therefore here we will get 4m square. So 4m square is can be written as m square plus m square, 2m square, sorry, this is 2m square. So therefore we will get here root 2 into, okay, this is the magnetic moment of the first combination. What about the magnetic moment of the second combination? So this is m and this is m and this is also m here. Now here this is a closed loop, right? So in a closed loop form between the according to the vectors, laws of vector addition to the net magnetic moment of this combination, it will be 0, right? Now third one. Now if you observe the third diagram here, one magnetic moment it is in this direction, the other magnetic moment it is in the opposite direction. Both are having the same magnitude but are in opposite direction. Already the net magnetic moment the net magnetic moment it is also 0 in this case here. Okay, now coming to the fourth diagram, the net magnetic moment. This is the direction of the one magnetic moment and this is another direction of the other magnetic moment here, and the angle between them is 60 degrees here. So therefore, according to the law of parallelogram, law of vectors prakaram, what you will get here, m square plus m square plus 2m into cos 60. Now what is the value of cos 60 here? Cos 60 value is equal to 1 by 2. So cos 60 and 2 get cancelled. So therefore m square plus m square, it is equal to 3m square. So therefore it is equal to root 3 times of m. Now out of these 4, which one is having the more magnetic moment? Root 3 into m. So therefore the option 4 it is the correct. So that is option 4 here. Let us calculate what is the vertical component of the Earth's magnetic field here. Now, what is the direction of the magnetic moment of the Earth's magnet? Magnetic moment of the Earth's magnet is in the downward direction from south pole to the north pole. Right. Now, if I extend this line here, this is lambda, this is also lambda, and this one it is 90 minus lambda. Right. Okay. Now, since it is a vector quantity, it is making some angle theta, so therefore it can be resolved into two components. So resolving into two components, we will get here in this direction, we will get m cos of 90 minus lambda. This can be written as m into sine lambda, and perpendicular to this one, and perpendicular to this one here, we will get the another component of the m value, which is equal to m sine of 90 minus lambda, which is equal to m cos of lambda here. Now suppose let us consider this is a magnetic moment of a magnet here. If I assume a magnet here, right, this is the south and this one is the north pole here. If I assume a magnet here, this magnet is having a magnetic moment m sine lambda, right, and this point P lies on the axial line of this magnet. Now here the point P lies on the axial line of a magnet. So here point P lies on the axial line of a magnet whose magnetic moment is m sine lambda, whose magnetic moment is m sine lambda. So therefore BV is nothing but B axial. Now what is B axial here? B axial formula is equal to mu naught by 4 pi into 2m. What is the magnetic movement of the magnet? What is the magnetic movement of the magnet here? M sine lambda by distance square. Now what will be the distance here from this point, from O point, the P point, it is at a distance of R. So therefore distance cube, distance cube. Because we have to consider the earth as a small bar magnet. So basically and this is the length of the bar magnet 2L, and M is the pole strength. M is the pole strength of the bar magnet, and the magnetic movement it is equal to pole strength into 2L. And what is the moment of inertia of the bar magnet here? It is equal to ml square by 12 of movement. So therefore the time period it is equal to 2 pi root of I by m dh. Now, if magnet in two parts का divide చేస్తే, if magnet in two parts का equal parts का divide చేస్తే, then what is the time period अडुगुताను? Time period of each part. Time period of each part अडुगुताను. Okay. So therefore, perpendicular to the length calculation చేసాం కాబట్టి, కట్ చేసాం కాబట్టి length of the each part వచ్చేసి L అవుతుంది. Pole strength వచ్చేసి remains the same. Right? Pole strength remains the same. Clear? Pole strength దేనిపై డిపెండ్ అవుతుంది? It depends upon the area of cross section పై డిపెండ్ అవుతుంది. So therefore pole strength అనేది సేమ్ ఉంటుంది. So therefore here the new magnetic movement it will be the new magnetic movement for each part will be. So pole strength of each part m into length of each part it is equal to L. So therefore here m into 2L by 2 and రాస్తాను. So m into 2L is nothing but capital M. So therefore capital M by 2. అంటే magnetic movement కూడా ఏమవుతుంది? half అవుతుంది. Okay. Now what about the moment of inertia? I is equal to moment of inertia, and I prime for each part is equal to m mass of the, here what we are writing this m, this is the mass, right? So mass exactly half అవుతుంది అంటే m by 2, right? Clear? And here L square. So L కూడా half అయిపోయింది కదా, అంటే L indicates the total length of the bar తీసుకుంటాం. ఇక్కడ మనం half చేసాం కాబట్టి ఇది L by 2 అవుతుంది. So L by 2 whole square by 12. So overall this one it is written as m by 2 into 12 into L square by 4. Okay, rewriting this one, I prime it is equal to L square by 12 into 1 by 8. Now what is ml square by 12? It is nothing but I. So therefore I by 8. So this is the new moment of inertia of the each part. Okay. So therefore T prime will be 2 pi root of moment of inertia I prime by m prime into bh. Bh it is constant. Okay. Now substituting this one, 2 pi root of I prime, it is nothing but I by h by m prime is equal to m by 2 into bh. Okay, now rewriting this one, T prime is equal to 2 pi into root of I by m bh into 2 by 8. So therefore 2 ones 2. So therefore it is equal to, now 2 pi root of I by m bh is nothing but capital T, and the root of 1 by 4 means it is nothing but 1 by 2. So therefore it is nothing but T by 2. So therefore the new time period of each part is equal to T by 2.